All right.
There we go. So, let's get started back up again. No, thank you. All right. Ubuntu.
That's what we should name our baby.
No, probably not. Change into the coffee shop directory. Fire up code, which means VS Code.
Alrighty.
I realized as I was thinking about it that I think I made a mistake in the way I set up our coffee shop day to run.
Like
and
what?
I'll try to explain that here in just a sec. So let's see. Get Kava running in the background. Okay, so the way we have our coffee shop set up right this second, I'll wait for this to finish loading. There we go. The way we have this set up right now, we give it a number of days, say we're giving it the number 5. Well, then that number 5 goes into this loop variable, or not variable, but loop form. It attaches the number 5 to day, and then it's going to use that down here. And it's going to check if it's less equal to 0, and if not, then it'll do this, and then it'll insert a day matching that day and give it 100 coffees. But that means we're actually doing this whole thing backwards. Instead of saying on day 1, do this, and then on day 2, and then on day 3, what's actually happening is we're going 5, and then 4, and then 3.
Okay.
But because this is a sorted map right here, that sorted map keeps everything in order. So even though when we run it, we get 1, 2, 3, 4, it's actually going in as 4 and then 3 and then 2 and then 1.
Oh.
So that's not best, because in the future, if there's ever something that happens on one day that's going to affect how well things go on the next day, we actually want it to be able to go in order like that. Like maybe if your customers are really satisfied on day 1, then more of them will come back on day 2.
Yeah.
So how can we fix this? Well, the problem here is that we're starting with our biggest number. So, and then on each day we're subtracting 1 from that biggest number. So to do that backwards, let's instead say we'll start with the smallest possible number, and then each loop, when it goes back through it again, it will inc, which inc is short for increment. So
makes sense.
Inc will take any number you give it and give you back that number, the next one up.
Okay.
Which is actually sometimes more helpful than like +1, because you can increment things that behave in specific ways. But anyway, we'll increment the day to go up. So we'll start with day 0, because that's normal indexed, 0 indexed things are pretty standard in programming languages most of the time.
Yeah.
We'll start with day 0, and then for this check, what's the purpose of this if right here? Like, what's it doing?
That's to check if all of the days have been completed, and then it goes, all right, we're done.
Yep, so that's where it breaks out. So instead of saying check and see if the current day is equal to 0, because we're going to start with 0, what does this need to be instead?
First guess is 5. I didn't count that out, though.
Well, that's if we gave it 5.
Right. But like it oh, so it would instead I guess it would have to be days
Yep.
instead?
Ever how many days we want to run
Yeah, okay.
for. It will check and see, okay, what day am I on? And this will begin at 0. But then after it runs through it the first time from this loop down into this recur down here, once it recurs, then day will not be 0 anymore, it'll be 1. And then it'll check, okay, is 1 equal to the number that I was given? Nope, still smaller. We'll keep going. And it'll go again and again and again until we hit the right number. So I think if I run this over here, it's going to look, except that we're starting with 0 now instead of starting at 1, it looks almost exactly the same as before. But I think the inner workings of it are actually correct this time. And it's filling things in from the bottom instead of accidentally putting them in the top and then not sorting them correctly.
Okay, so can you fix the starting on day 0 thing by just adding +1 to everything?
I could, yep. Or we could just start at 1, and then instead of saying, because this one over here, we're running it for 4 steps. So if day becomes greater than days, break out of it. And that would do the same thing, but we go 1, 2, 3, 4 instead of 0, 1, 2, 3.
Okay, there we go.
Yeah. So
nice.
Do you think, would you prefer to have it day 1, day 2, day 3 instead of day 0, day 1, day 2?
That sounds like a more user-friendly kind of thing, yeah.
All right. We'll go with that. So, another thing that I wanted to talk to you about is the idea of a map. Do you know what a map is? Like the data structure?
No.
So that is what we're doing over here, where we've got something that goes in first and something that goes in second. And then, so a map in Clojure and in many other languages is a set of pairs between a key and a value. So in Clojure, those keys and those values can be anything. The key can even be a whole nother map. And that's what we've got going on over here. So I'm just going to copy this over and we'll expand it a bit so we can actually see what's going on here. So we've got 1, 2, 3, and 4. But within, so this is the key. Key is that right there. And then this is the value over here.
Okay.
But this value is a whole new map. See?
Yeah.
So then within this, this is the key, and this is the value. Right?
Right.
So why do we do it that way? Well, one reason is that everything that goes in there has a name, and so we can actually tell them apart. So right now, each day is just 100 coffees. There wouldn't be a way to know which one we're dealing with unless we put in there something that says this is what day that came from, and then we can actually go and find that again. So at some point when we figure out how to put a chart together, these numbers are actually going to help us keep the data for each day in the right order.
Okay.
So one interesting thing about Clojure, I told you everything's a function in Clojure, right?
Yeah.
You can use a map as a function. So if I give in, let's back up. In order to call a function in Clojure, you put it in parentheses, and whatever the first thing is inside of parentheses, it's going to try and use that as a function.
Right.
So right here, I'm putting in this map as the first argument right after parentheses. So it's going to treat this like a function. It's going to try and run this. And if I give it an argument, the effect of that is it's going to go get whatever is in there that matches to that key. So I've told it, go get me. Let's change these to make these a little easier to read.
Get key 1.
Yeah. So if I give it a 3, it goes and gets the value. Sorry for all these pop-ups. It goes in and gets the value that's attached to that key.
Okay.
So that's how we'll get this information back out again later when we have something else to plug it into.
All right.
Make sense?
I mean, I think the only question I have is, like, you started using the kind of map of definition to start, but then you started using it. Yeah, it's keys. And that sounds like a different thing.
So this is how I tell Clojure, well, specifically how I tell spec, because spec is the add-in that contains def and conform and valid and a number of other functions. So spec has keys as a way to define when I give you a map, it should have these keys in it.
Okay.
And so this implied here is that it's going to have a value of some kind to go along with it.
Okay. So, like, I guess the kind of explanation or elongation of the syntax is you're defining this thing, and then this is already assumed to be like a key, and then, or like a map.
Mm-hmm.
It's assumed to be a map, and then you're saying, okay, this map has these keys.
Right.
And then these keys have these values.
Yep.
Okay.
Yeah, because a map is the only thing that has keys. So if I'm using the function that says, when you get something, expect these keys to be in it, that by definition already means we're talking about a map. So it's clear enough by saying, look for these keys to be in there. And then, so this is the example that we had right here.
Right.
So then key is core milk. Value is a whole new map. And then the key is espresso, or core / espresso. And then the value is a whole nother map. That's how that works.
Gotcha. All right.
Okay. So I realized we were using those already, and I hadn't actually explained what they are and how they work. All right.
Okay.
So we fixed our order of operations. I got to make sure I'm not leaving this file all cluttered. I don't know if I'm supposed to use. Yeah, we'll use double. So because the way the REPL works, when I have something to just type in, it gives me this equals arrow. That's like the standard convention for when you've run something. And that's why this shows up that way. Is because in Clojure, that equals arrow means this is what was returned by trying to run that. So in this comment, I can say coffee shop for 4 gives you back, and then I'll copy this. So like just as an example, when you run this function with this argument, this is what you would get back. And I can leave that in there as a comment. Just so I have an example of what that function would actually give back. This may or may not be necessary, and I won't do that all the time, but I'll go ahead and leave one in there.
Okay.
Okay, so we've got a delicious coffee drink, which is a latte. And we've got a core loop for running each day. I thought there's two directions that we could go next. One is, it seems to me that it might be interesting to break a day up into shifts, like a morning shift and an afternoon shift and an evening shift.
Hmm.
So we could do that. Or we can start to talk about what a barista is going to look like in our coffee shop. Which one of those would you like to go with next?
Um, well, still kind of making this up to be more of a game than a simulation game. Um, Breaking stuff up into shifts sounds like it adds more opportunity for decisions to happen,
Mm-hmm.
and then decisions is where interesting stuff happens.
Mm-hmm.
So I'd like to start with that, I guess.
Agreed. I think that's a good idea. So I made myself a note or two just so I have an idea. Okay. So right now, when we run this coffee shop thing, it's kicking out a map of. Here we go. Actually, I guess this is what should be in here, not the other thing. It's kicking out a map of what the day number is and then what happened in that day.
Hmm.
So, in order to show shifts happening, let's have a number for what day it was, and then a map that's going to say whether it was morning, afternoon, or evening. We'll just start with. And then in there is where we're now going to have how many coffees got made.
Makes sense.
This. There we go. So that's what's going to come back after each day, and then 2, and then 3. Like so. So that means that this spot right here is where we need to make a change. So instead of just spitting back, here's 100 coffees. Let's say at that spot we're going to have a brand new function. And I'm going to call that run for one day. Run a day. That's not a thing yet, so we got to define it. So we'll say define run day. So right now it's not taking any inputs. So if we want these 3 pieces to come out, morning, afternoon, and evening, one way to do that would be to hard code in here and say, all right, just send back this thing right here.
Mm-hmm.
Like so. And if we save this and this, and then we come in here and actually run this, that'll give us what we just talked about. Where we've got on day 1, there was morning and there was coffee, and there was afternoon and there was coffee, and there was evening and there was coffee. And then on day 2, blah, blah, blah.
Yeah.
But we're still kind of hard coding in these values for how much coffee got made. And it seems to me like that would be more interesting if it was more variable instead of always being exactly the same. Right. And morning is probably you're going to sell more coffee in the morning than you would in the afternoon and the evening, because people just they're not buying as much coffee, it seems to me. So
yeah, it just makes sense.
Let's say we're going to have a random number, a random integer, and we're going to tell Clojure, okay, how big of a number do we want? From 0 to, is that how I think this works? Yep. Returns a random integer between 0 and n, whatever n you put into it. So just to throw some numbers out there, let's start with a random number between 0 and 50, and we will add that to 75. So if this is 0, it would end up being 75. If it's 50, it'll be 125. And so we've got some buffer above and below 100 now. But
Okay.
this wouldn't work. I need to add these together. Right? So
Right.
there we go.
Cool.
So we'll do that for these other ones. And then just make the numbers a little smaller. Do that. Maybe.
All right.
So this will end up being somewhere between 30 and 50, with 40 being right in the middle, and this will be somewhere between 10 and 20, with 15 right in the middle. So let's save that, and then try it. There we go. So that ends up being a little bit more interesting. On day 1, we sold a lot of coffee in the morning. On day 2, a little less than that. On day 3, a lot less. On day 4, the least of all. But then, they kind of average out a little bit. So that's one way we can do this. Another way that we could do it, that I think will probably end up coming in handy later when we complicate things a bit more, is to say, instead of running an entire day all at once, let's have a function for run each shift. But I don't want to have run morning shift and then run afternoon shift and then run evening shift, right? That's obnoxious. So instead, I will take as a input into the function, what shift is it that we're actually trying to run? And then I will use an interesting Clojure function called case. What case does is you tell it what to look at. In this case, I'm using shift. And then after that, you tell it, okay, if it matches what I give you next, here's what you do. So I'll say morning, afternoon, and evening. In that case, then we will have it give back just this bit right here. So actually, I will copy this entirely, put it up in here.
All right.
And then when we're running the day, we will just always plan at the moment to run a shift with morning, and then run a shift with afternoon, and then run a shift with evening.
Okay.
And then put those into a map like this.
Okay, so question.
Mm-hmm.
Is making a map of something with a key having the same name as that key's values key thing? Like, does that confuse things?
I don't think so. So let's try. Yep. So we just have a map where the key is Caleb and the value is Caleb.
Okay.
This, by the way, when you have a single colon before something, that means that this is a keyword. It means it doesn't do anything except you can compare it to see if you have the same keyword more than once or not.
All right.
So
Neat.
this keyword is not allowed to represent a function or to be turnable into a number. The only thing that it's good for is being a unique identifier for things like setting as the keys in maps.
Okay. Because um, the kind of, I guess, concern I would have is like the same way you would have something like a variable is the same, is equal to like itself, which is then equal to this.
Mm-hmm.
And so you go like, oh, what's this value? And it has to compare itself to itself. And it just goes,
Yep.
and so it would get confused.
Yeah, so in Clojure, I'm pretty sure a a keyword is always equal to a keyword that's spelled exactly the same because it can't have anything else in it.
Okay.
So a keyword does not have any additional details, which means there's nothing that could possibly be different between two different examples of the same keyword. So when
All right.
you compare them, they'll always end up being the same as each other.
So you're not going, ooh, what's in this set of something?
Mm-hmm.
And then it goes, ooh, it contains me. And it's just going, oh, hey, name. What is the map that's or thing that's associated with you?
Yep.
Oh, it's this, and it
Yep.
also just so happens to have the same name. Gotcha.
Exactly. So
Okay.
that's what's happening here. Remember, the first thing that's right after parentheses is a function call. So when this
Right.
runs into run shift, it goes over here to figure out what run shift means. And whatever's after that is the arguments that go into that function.
Right.
So when we run coffee shop here in a second, it's going to go in here and say, okay, blah, blah, blah. This is just checking to see if it needs to run another one or not. There's probably shorter ways that we could do the same thing, but we won't worry about that for a second.
Right.
Actually, it just popped into my head how we could probably do that differently, but we'll finish what we're doing for 1 sec, and we might come back to this. It's going to get down to here, and then it's going to say, okay, for day 1, go ahead and run the function run day. All right, sweet. Then we come up here, and then it runs into here, and it says, okay, make a map. Make the first thing in that map a key that says morning, and the value is going to be whatever you get back from running the function run shift when you give it morning, the keyword, as an argument.
As the keyword. Okay.
Then it'll go up here and it'll say, okay, so take morning and stick it in there. What happens? We go to this case switch. It'll say, okay, use what you got in and then compare. And when you find a match, do that thing. So then, since we gave it morning, it'll stop at this first one and then go in there and do that. So
All right.
functionally, and I don't mean that as a pun, this should be exactly the same as what we did a second ago. We just made it a little more complicated. So instead of doing a whole extra function call into here in order to get this back, if we were stopping here, it would simplify things to just go ahead and put this right there instead of doing it as a function call. But I think because as we go, it's going to get more complicated and we're going to want more stuff happening for each shift. Like each shift might have different employees working for that shift. So having it separated out to where we can add additional things here, like who and where and blah, 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 I think that's going to make things in the future easier to figure out. And if not, we can always turn it back into the way it was.
Very cool.
All right, I think I figured out a better way to do this. So one good idea when you think you figured something out is to copy it and then comment out the old one so that if you break it, you can at least go back to the one that you had before. I think
Sounds like a good idea.
If we're taking in a number and we want let's see. Let's say let instead of loop. History sorted map. And then do times. I think that's right. And then just this assoc can go right there. And the rest of it we can get rid of.
So that's going to pretty much do the same thing, but with this shiny new function, it'll just say do the number of times that you just gave me.
Yep. Got to remember to give back the thing once it's done updating it. But did that not work? Do times. Oh well. This is why we saved a copy. So I can always back up if I had a brainy Smurf idea and it didn't end up working out. I'm pretty sure there is a simpler way to do this. Like, I'll tinker with it later.
Sounds good.
All right. So one last thing that I would like to hit real quick is how would I share this with somebody who is also trying to develop this program? So if we got you set up with a Clojure environment on your computer, and I've got one on my computer, and we both want to be making updates, how do we do that? And especially if we get a third person involved, now it's really complicated, because if somebody changes something and then it breaks, then how do we know how to get it back to what it was? It can get really complicated. And the other thing is, this only exists on my one computer right now. So if I accidentally drop my backpack on the ground on the way to school and then drive over it with a big truck, which I don't expect will probably happen, but it could, then all of this is going to be lost. And so far, we haven't put too much time into this, but you know, if you've got a larger team of people that's working together on something, you can end up getting dozens or hundreds of hours of time put into a larger and larger project. So what's a good way to save this so that it works for collaborating? It's going to save a copy of it somewhere, and it'll give us a change history so we can see what changed over time.
This sounds to me exactly like GitHub.
This is exactly GitHub. You beat me right to it. That's perfect.
Sorry.
Have you used Git before?
I used it a little bit, especially for pushing logsec notes so that I didn't have to worry about what device I was on.
Yep. So we're just going to use Git.
Yeah. And then logsec became a desktop app, and you couldn't do that anymore. But that's not important.
Well, I think you still can. You just would go into the folder on your computer where those files are saved, and then you could make a Git repo right there. So let me check and see if I have Git installed in this copy of Ubuntu. So Git, looks like I do. So I meant to say Git version Yeah, so we've got Git. All right, so in order to get started, Git and GitHub are not the same thing. They're not owned by the same people, they just work well together. Git is a program that's local on your computer, and GitHub is a repository. Well, it's like a repository of repositories that is publicly accessible, or you can set it to private. But that's on the internet. That's called a remote host.
Hmm.
You can use Git without ever sending it to GitHub, or you could send it to somebody else like GitLab, or you could use Git to collaborate with somebody else directly between your two computers.
Okay.
So first, I'm going to tell Git, because I'm in my coffee shop folder right here. I'm going to just show what files are in here. So right now, it's the same as these files right here. So the different folders, I'll collapse those so they look the same. So these files are these files. These blue ones are folders. That's those folders. And by default, when I hit ls, if it has a dot in front of it, that tells it that that can go in the background. If I hit -a, then it'll show everything. And so this is exactly this. So I'll start by saying Git that I want this to be a repository. I want it to start tracking things. So I'll say Git init. So initialized an empty Git repository in that folder. And you saw all of this changed colors. That's because VS Code knows how to talk to Git. So at this point, I can stop even using the command line, and I can switch back over to VS Code because VS Code knows how Git works. So an important thing when you're setting up your Git repository is there are certain things that you're just not going to want to include. Looks like we have a git ignore file already set. So if it's in any of these folders or it's any of these files, just go ahead and not even include that. So updating git ignore, and then I have to configure another piece of Git. So I think it's git configure, but I'll say help.
Yeah.
Let's see.
Oh, I do see config out there. Yeah.
Very good. Okay. So git help config. Global options. Normally, by this point, I would already be Googling it. So why don't we actually go ahead and do that? Help me remember.
Yeah, let's be realistic.
Git config. There we go. That's what I wanted right there. Git config -- global user.name. So that's what I'll do. Git config global user name me. Config global user email. There we go. Okay. Now, let's see if this will let me make a commit. Yep. Sweet. All right. What is all this? CLJ Condo. Okay, so CLJ Condo is a program that Calva has been running that helps spot when I wrote something incorrectly in a Clojure file. It stores a bunch of information that I don't actually need to be like part of the program. If I was to try and re-download all this somewhere else, it's not that important to me that this CLJ Condo or this .calva or this .lsp, I don't really need those to go into the GitHub. So I think if I add a /calva or .calva /.clj condo and /.lsp, then those just went gray.
Hey.
So now those are not going to come along when I commit things into the Git repository.
All right.
So for right now, I can just add everything in the whole repository and say start tracking this. So I'm going to say initial commit. Boom. So now, in the background, Git has taken a snapshot of exactly what all these text files look like, exactly the way they are right now.
Nice.
So then I can add a remote repository. I'll go ahead and make it public because why not? Here we go. So then now, if you want to see the little project that we've started, you can go to github.com/cfigures/coffeeshop, and that will take you right to it.
Yeah.
I put it
Okay,
in the
well,
chat
I'm
for you.
using search to do that on the GitHub website.
Mm-hmm.
I guess that's not going to work.
It should, but it might take a second before it catches up because this was only like 30 seconds ago, and GitHub is huge, and many people use it. Yeah. So eventually, we should probably update this README so that it will actually explain what this is and why anybody ought to care. But I'm not too worried about.
Well, I found the code.
Okay, sweet. So if you wanted to get this code so that you could tinker with it yourself, here is how you can do that. One way is to grab this same URL, and then I'll say, so say I'm over here, I can say git clone and then that URL. And that goes and gets it. So now then, if I look in here, there's Coffee Shop.
Hey.
And that's a different one from the last one, the other one that we've actually been working with, because I just made this new.
Nice.
Okay, so clean that up real quick. So that's how you can do that. You can just grab this URL and then say git clone and that, and it will go and grab that down for you almost instantaneously.
Nice.
There's other ways to do it, but that's an easy one. If you're That's easiest if you're going to be using Linux of some kind. So if you set up the Windows subsystem for Linux on your computer and then you do it this way, then that would work. If you were trying to do it on Windows, I don't know. Let's try Git. Okay, I've got Git installed on Windows even. So let's say Git clone. And then you got to know where to look. But oh, that's not the place to look. Users, me, coffee shop. There you go.
Hey,
So there it is on Windows.
neat.
So that's how GitHub is supposed to work. Some people that have never used GitHub before and don't know the correct way to interact with GitHub, the way to interact with GitHub, the best way, is to have Git installed on your local computer, and you use Git to clone the repository from somewhere else. And then that means
Gotcha.
that it also brought along with it the information that it needs to send stuff back up to Windows. So if I'm over here in Windows now, if I go in here, and this is our Clojure file that we've been using so far. Open with, I just want like the notepad or whatever. Anyway, if I made a change to that, then I could come over here and say git add that change in, and then git commit with a message, this is what I changed. Or if you're using VS Code in Windows, because VS Code is multi-platform, then you could just use the same interface that we were using before. It just wouldn't have Linux on behind it. It would have normal Windows.
Okay.
And then you could push commits up to GitHub. And then the next time that I come in here to make changes to it, then I would sync and it would pull your changes back down. And then we could be synchronized.
Okay. So about that, is that a pull request to commit to the main branch, or am I just straight up doing it? Because then,
Yeah, if so that's in how GitHub works. So pull this up. So GitHub is up here.
right.
My computer's over here. Your computer's over here. So here's what we would do. I just made a coffee shop program. Then I
Boom.
pushed that up to GitHub. Like so. What you would do now is fork the coffee shop. If you wanted to submit up a new change into this coffee shop thing, you would fork it, which is grayed out for me because I'm the owner, so I don't really need to fork my own repo. But you would click fork. What that would do is make a duplicate of this under your GitHub instead of under mine.
Okay.
So
And then,
this is fork. Then you would use Git on your computer to clone it down onto yours. So then you would have this over here. Then you make changes, right? Now it's coffee shop v2. And you commit those in your local Git repo. Then you would push this back up to your version.
okay.
This is called push. So now this is coffee shop v2. and then you would submit a pull request.
No, that's hey, this is really good. Put this as the main thing
Yep,
instead of my own personal version of it.
yep. So then that's how
Okay,
this would get to be Coffee Shop V2. And then
neat.
I would sync this back down again. So this was pushed, pull, and then the version on mine would then be V2. So that's how that works. That seems a little obnoxious, like 4 different steps to go through. Uh, but think about if instead of just 2 people working on this, if there's like 18, you know,
Yeah,
like if a whole bunch of different people are all working on this thing, then
and
having
they're all named
this
Seth.
this little bit of structure. Wow, this is Seth 6. This is Seth Electric Boogaloo.
Nice.
Seth 2 Electric Boogaloo.
Very good.
Having this set up where each person who wants to work on this forks their own version of this means that you will never mess up somebody else's
Hmm.
when you're making your own changes to it. And then when you do a pull request in order to try and merge those changes back into kind of the main version that everybody's using, somebody has the ability to check off on that and make sure that it's good and that it won't break something. Not just anybody can do that.
Yeah, so
So
plenty of redundancies and opportunities to keep stupid people from breaking your code.
exactly, while allowing really smart people a very clear way for them to come along and find stuff in your code that ought to be better. So for that matter, let's go into this core.clojure. This coffee shop thing right here. That right there.
They go, hold on.
I'm gonna say right over top of that, to do. Figure out how to do this with less running around in circles. Save it. Come over here. Because that's a saved change, it'll go there. Then I can say added a to do. Commit that. Sync it.
Boom.
There we go. Now there's a to do. So if you or somebody else or whatever were to happen upon this and then see to do, figure out how to do this, you might go, huh, I think I could do that. You go up here, you fork the repository, you figure out how to solve that problem, bring it back, and you're good to go.
Nice.
So that's how people, even people who don't really know each other, can end up collaborating online in order to make really, really cool stuff. And that's the whole idea of open source programming.
All right.
All right. So that's a couple different things that we ran into. It was we fixed the way dates were, or the days were running, so that they actually go in order instead of backwards. And then we kind of split out each day into being a couple of different shifts, and then put the whole thing together. We talked a little bit about how maps work in general, and then we added all this to a Git repository and then synced it to GitHub. And now you know how to do all those things. So
Yes.
still to figure out is baristas, customers. Those are the kinds of things that we'll be thinking about next.
All right. I feel like I really just want to start learning Clojure and then pulling this into my own computer and break it 50 different ways.
Clojure
Sounds
is
neat and fun.
it's pretty fun. And one of the cool things about Clojure that maybe we'll talk about next time is there's flavors of Clojure. So I'm using like the basic default Clojure. Clojure that runs on the JVM, and then all of your Clojure programs, when you compile them, they're actually running Java bytecode. There's a
Okay.
version of Clojure that uses the same syntax. It uses the same parentheses and rules for what counts as a function and all these different things. But when you compile it, it compiles to JavaScript, which means that you can write Clojure programs, but then like this web page that's running Brave on it is actually some really sophisticated JavaScript. You can do really cool things with Clojure script, and you're learning this style of programming instead of the JavaScript style of programming.
But then they kind of translate directly, and you can just
Mm-hmm.
go, work, and then it
Basically,
does.
or if you solve a particular kind of problem in your Clojure program, and then you're writing a Clojure script program because knowing Clojure, you're basically automatically multilingual because you can write things for the JVM, you can write things for the browser, you can write.
Mm.
Um, there's a couple of other like smaller dialects of Clojure, but you're learning all of them at the same time. The better you get with the basics of how Clojure works, you're actually getting better at all of those different applications. If you solve an interesting problem in one of them, then you can reuse that solution somewhere else because the code is the same. It's just going to compile it different once it actually turns it into something usable.
Hmm. Cool.
Yep. So if this
And
has made you interested, I recommend it. There's a couple of books online that are free. Closure for the
oh, I love
brave
free stuff.
and true. Learn to program the world's most bodacious language.
Bodacious.
It is
You can tell they're
bodacious.
smart because they use big words.
Oh yeah. So start reading now. And it's a couple of years old at this point, but an interesting thing about Clojure is they kind of figured it out right the first time, so there's not a whole bunch of changes that they have to make. So even though this book is not brand new, it's still like exactly what you need to know.
Hmm.
So if you're interested
Cool.
in independent study, check out Clojure for the Brave and True. I'll put that in the doobly doo.
I will check that out because I was doing Python first, and then I fell off a little bit, and returning to it after I had already learned a little bit, but not enough to be fluent.
Mm-hmm.
I realized, oh, I don't know exactly where I left off, and I'd have to start all over, and that was really demotivating.
Yep.
So if I want to get back into code, I just want to pick up a new language entirely, I think.
Yeah. Clojure's really interesting. Um, so you could definitely go worse. Uh,
Yeah.
a lot of people who've been programming for a really long time, like 20, 30 years as programmers, end up finding Clojure later on, and then they just stick with it from that point on. And they're very,
Hmm.
very satisfied, which I think is pretty cool.
Yeah. And the same way that people go, hey, if you just need to learn coding for anything, pick up JavaScript, it'll just work.
Mm-hmm.
I mean, Clojure translates directly to JavaScript, so
Exactly.
it has that advantage to it.
Yep.
So cool.
Cool.
Nice. I'm not gonna do this tonight because it's 10:30 and I should probably go to bed soon. But tomorrow I might have some reading to do.
Yeah, check it out. It's very easy to read. It does not go overly complicated, and it's got lots of examples that you can do yourself in order to check it and make sure that it's working. He's not using an editor environment like VS Code. So if you get VS Code set up, then you can that can be like your problem solving is okay, he did this, but he's just using the basic command line. How would I do it using VS Code with Calva or some other text editor setup?
Yeah, because you have special commands with spec that you don't have for the base coding thing, right?
Well, spec is a library, but it is included in Clojure the language. Anytime you have Clojure the language, spec comes along with it, but you have to declare that you're going to use it in a given file, is how that works.
Okay. Gotcha.
Yep.
All right.
Cool. Well, I'll let you go. Thanks for hanging out with me, man.
Thank you.
Mm-hmm.
It's been a grand old time.
Fantastic. All right.
I
Love you.
love you a lot. Yes, sir.